It means discontinuity.
This.
Says something that stops. Yeah, something that stops.
The graph doesn't go through that point.
Okay, yeah. What does this mean though?
Like this.
Not
Oh.
continuous. So we're going to talk about graphs that are not continuous. There are 3 different types of discontinuities, okay? You don't have a homework over this per se, but this is a test question, okay? So we're going to talk about it. Then when I come back tomorrow, when you watch the video, it's over piecewise functions. And then when I come back Monday, Tuesday, and Wednesday, we're going to graph all next week. Make sure you have graph paper. I do have some in the white bin up there if you don't have any. Okay, so let's talk about the types of discontinuity. The first one is infinite, and that's where, or when I should say, instead of where, when the y value rapidly approaches positive or negative infinity. So I'm going to draw an example of what that could look like. And we're actually going to graph this in chapter 4. So we're just going to do a sample. So if I draw in, let's say this is x equals 2. I'm going to draw in a vertical asymptote, because this is only going to happen when there is a vertical asymptote. Do you all know what a vertical asymptote is? We talked about this in Algebra 2 when we graph logarithms. An asymptote is like a wall that you can't cross or go through, okay? So anytime you have a vertical asymptote, and again, this is going to be at x equals 2, you can have a function that's going to approach that point, and then when it gets to that, because it can't go through the wall, it just goes straight up. These are examples of what it looks like, by the way. This is an example of what it could look like. It doesn't mean that on both sides, one is going to go up and one is going to go down. They could both go up or they could both go down. So that's your first type of discontinuity, is an infinite. The second type is when you have a jump. And the jump is when your y value changes. Okay, so for example, and this is a piecewise, which is what the video is going to be over tomorrow. We can have a function that starts off linear. When it gets here, it stops. And then at that point, the graph is going to either jump up or jump down. So I'm going to say it jumps down. And it can look like a parabola. That's a jump. So at this point, again, which we don't know what this is, we'll say it's 2 again. The y value changed rapidly. It went from positive something to negative something. Now, why can't they both be closed circles?
Because it jumped.
Because we can to show that they came from that.
Remember on the test, it said the definition of a function. If both of these were closed, that means that x2 would have 2 different y values, okay? Which means it can't be a function. And everything we draw has to be a function. So you can have 2 open circles, but you can't have 2 closed circles at a jump. And then the last one is when you have a hole in the graph. And it literally looks like a hole. So I'm going to draw. It's easier for you because you can actually erase. But I'm going to draw a parabola that has a hole. So here, it actually looks like a hole in the graph. Those are your 3 different types of discontinuities. So infinite, jump, and a hole. All right, so let's look at these pictures. Let's go ahead and zoom in. Looking at A, what kind of discontinuity do you think that is? Removable, right. Does everyone see how it's a line? There is a line, and in that line, there is a hole. Okay, right here, there is a hole, and that's right here where x equals 2. So what you would say is that at x equals 2, we have a removable discontinuity.
Wait, at x equals.
Oh, I didn't mean to put -2 at +2. Thank you. Because it happens right here. Where x is 2. So right here when x is 2, do you see how we have a hole in the graph? So at x equals 2, we have a removable discontinuity. The other thing I like to think of is when you notice that this is like a sidewalk. If you're walking on the sidewalk, we just have to hop over the hole. When it's a jump, like we have in question B, if I'm walking, in order to get to the next graph, do you see it's a jump? Yes. You can't just step over that. You have to jump. So this has a jump at what? X equals what? At x equals 0, we have a jump. And then at C, we have our vertical asymptote, and we have at x equals 2 an infinite discontinuity. So one thing that you have to do is identify what kind of discontinuity we have. So now let's look at graphs that have a lot. So I'm going to zoom in really close to D. This one has it has all 3 discontinuities in one graph. It is, and we're going to graph them. So my first discontinuity happens right here at x equals -4. What kind of discontinuity do we have right there? Infinite. Then my next discontinuity happens right here, and that's at x equals -1. What kind of discontinuity is that? A removable. And then my next one happens right here at +2. And what kind of discontinuity is that? Jump. All right, go ahead and do E by yourself. It should be 1, 2, 3, 4. E has 4 discontinuities. So I want you to tell me where they are and what type they are. All right, at this first one here, what kind of discontinuity? So we have one at x equals 0. I'm going to write where we have it at. So x equals 0, x equals 2, x equals 4, and x equals 6. That's where the graph is not continuous. What's happening at x equals 0? Infinite. Who agrees? Okay. What about at x equals 2? Removable. What about at x equals 4? Jump. So to get from here to here, see, it's disconnected. It's not connected. So I have to actually jump to hit that next graph. And then at x equals 6, what do we have? Who says removable? Who says jump? Nope. It's a little hole. So if you think of this as a sidewalk, if I'm walking, I just have to stay on that line. I just got to hop over that. So that's a removable.
Why is that point there just a trick?
Yes, and we're going to talk about that later. What that means is that at f, if I were to ask you what is the value of f of 6, the value of f of 6 is 4. But we'll talk about that a little later, like how to evaluate. And that's actually a lot. We do a lot of that in chapter 4. So we'll kind of leave that blank for now. All right, let's look at f. I know these graphs aren't that great. So I see 1, 2, 3. I see 4 again. 1, 2, 3, 4. Go ahead, identify those 4. So our first one happens at x equals -2. Then the next one is at x equals +1. And then it looks like if you were to draw in a dashed line, that would happen at x equals +2. And then we got another one, 3, 4, 5, 6, 7 at x equals 8. Who had those 4 x values? So what do we have happening at -2? So if I'm walking, this is my little sidewalk. I'm walking. I have to jump to get to the next graph. So that first one would be a jump. Then when we get to +1, we have an infinite, because there's a vertical asymptote that's forcing this graph to go up to +infinity on the left, down to -infinity on the right. Oh, I skipped one. Sorry. Let's go back to 1. Before we even get to the wall, we have something else happening right here. Right here. There's a little hole happening at 1. Before I even get to the wall, I have a hole at 1. So we have a removable. And then at 2, we have our infinite. And then our last one at 8, what do we have here? What is that one? Who says removable? Yep, I would agree. Okay, so now let's do your practice test questions, because this is what you're going to have to do. You're going to have to draw a function. So let's work on example 2. We're going to do some practice together. So you would have to draw me an example of an infinite discontinuity at x equals 2. So before you get started, I'm going to show you some examples that I've gotten that are wrong. Okay. So anytime I see infinite, the first thing I'm going to think about is I have a vertical asymptote. So I'm going to draw in a vertical asymptote at x equals 2. So this is what a lot of kids do. What do you think is wrong with that? Yeah. That's kind of the attitude, right? But first of all, this graph is wrong for a couple of reasons. First reason why it's wrong is because this arrow is implying that it's going to go through the wall, which is illegal. You can't do that. The second thing is it has to approach infinity at the wall. This is going up away from the wall. This is going down away from the wall. So this would not be okay. And I'm just going to show you, so I'm just going to show you an example. And I want to make sure you understand that this is not just one, there's more than one way to do it. So you can either draw a graph that's going up on both sides at the wall. That's one example. Or you can draw a graph that goes down at the wall on both sides. Or you can draw a graph that does opposite. It doesn't matter which one you do. This would be an example. This would be perfectly acceptable on the test because it's an infinite discontinuity. For a removable, I would encourage you to draw any kind of graph you want to draw. Okay? Draw a graph. You can draw a parabola. And then at 3, put a hole. Or you could draw a straight line. Put a hole at the 3. You can draw just about anything you want to draw. I'm going to just make it simple, and I'm going to draw just a horizontal line. And then at 3, anywhere along this line. It doesn't have to be at 0. It could be at 6. It could be anywhere along x equals 3. There should be a hole. I'm going to put my hole down here and just make a straight line. That's an example, though. I'm only showing you examples. That's B. All right, let's flip it over. A jump, that means at -4, I need to make a change. So I'm going to put at -4, let me see, 1, 2, 3, 4. I'm going to put a closed circle somewhere. And I'm going to put an open circle somewhere. And I'm going to make sure that they do different things. Like that could be a jump. That's an example. All right, so now I want you to try to draw an infinite at D, and then I'm going to look at your paper. And I'm just going to tell you if it would be good enough. First thing you should be drawing is a vertical asymptote at -5. So at x equals -5, I need to see a vertical asymptote. That's the first thing you should do. Okay, so this would fail the vertical line test. So remember, everything you draw should pass the function test. This passes, these two fail. If I draw a line, do you see how it crosses through it twice? So they both can't go to the right. They gotta do opposite things. It has to pass, that's why I put must pass a vertical line test. That fails the vertical line test. Okay, I'm doing two things at once. Nope, that fails the vertical line test. It has to pass a vertical line test. That would be okay. That would be okay. That would be okay. That's okay. That's okay. All right, so let's talk about it. So at -5, I'm going to talk about what I saw that was wrong, because this is good. This is teachable moments here. This is what I saw a couple of people do. Do you recognize that would fail? That's why I put in yellow. Has to pass a vertical line test. If I can draw a vertical line and it fails the test, that means it's not a function. And that's what I'm going to do on the test. It has to be a function. It has to pass the vertical line test. So a sample would be, they have to be on opposite sides of the asymptote. They can't be on the same side of the wall. If it's doing the same thing, if it's on the same side, that's going to fail the test. All right, let's look at E. Draw an example of a jump. At x equals 2, it has to pass a function test. Jump it to removable, fails.
Yeah.
This is close. These two. Let's see what that. Good. So they should both be at 2 though. See how this one is having a -1? This needs to come over. Because they both have to be like, I can't jump. I'm falling out. I need a sidewalk right here to land on. Looks good. That looks good.
That's right.
That looks good. That looks good. That looks good. They're going in the same direction. That's not gonna work. That fails vertical line test. That looks good. Can everybody hold them up so I can see it? Good. Good. I'm missing half. Oh, I see it now. That's good. That, I can draw a vertical line. That's gonna fail my test. That looks good. Looks good. Looks good. Good. That doesn't work. Vertical line, it needs to go to the, that fails the vertical line test. That looks good. All right. So an example would be at 2. Whenever it's a jump, I usually put an open and a closed circle somewhere at 2. So I'm gonna put an open and a closed. Then it has to go opposite directions. They both can't go this way because that's not a function. One of them needs to swing to the left. There we go. That would be good enough. All right, draw a removable. I think removables are pretty good. I'm going to just draw one with you real quick. So -2, I'm going to put a hole somewhere and then just draw a line. Don't even have to be fancy. All right, so now let's talk about when you have to do more than one, because on the test, you're going to have to do more than one. So I need you to draw me, you should probably use pencil. Draw a removable at -3 and an infinite at +4. When you have one, raise your hand, I'll look at it. That will work. That works. That works. That works.
That's gonna be about this.
That's just one piece. That's one question.
Wait, so.
One,
So
2.3.
the half of the quiz we just did, is that gonna be on the test too?
Yes,
That's it. Well,
right here.
I'm sorry.
Oh, it did happen.
It fails the.
Oh, wait, wait,
Right.
All right, bro.
That looks good, but this one was not.
Wait, wait.
So I going on. I'll fail my test. That's good.
You failed the test. We got eight.
I think a lot of you all trying to do like superhero stuff. Don't be a superhero, okay? We just gonna be, we're gonna be basic. No, we gonna be basic. We gonna be real basic. So what I recommend you do, and I'll go back and look at it, is just draw your infinite discontinuity at 4. So at +4, I'm going to draw my infinite discontinuity. And then at -3, put a hole. Done. That's it. Like, we don't need to have like 7 or 8 different things. Like, make it simple. Less is more. All right, last one. Go ahead and draw J out. And then that's it for today.